So in this topic, we will discuss about collisions. What are collisions and what are the different types of collisions? That is what we are going to discuss right now. The definition of collision when we are looking, it's like this way. It's a short duration interaction between two bodies or more than two bodies simultaneously causing change in motion of bodies involved due to the internal forces acted between them during this. This is the definition that is given. So what does it mean? So it's a short duration interaction between the bodies. Not necessary that only two are interacting. It can be two or more than two objects interacting each other for a short duration, and which might be causing some change in its motion. That is collision. So now this collision, when we are looking, it is classified in general into two. So we are going for the classification right now. The basic classification is elastic and inelastic. Elastic collisions and inelastic collision. Now we will see what are the main properties of these two types of collisions. Or else we are going to see the characteristics of this. First of all, when you are looking to the elastic collision, so the main point over here is elastic collision. You can tell momentum is conserved. Then here, the total energy is also conserved. Not only the total energy, the kinetic energy is also conserved over here. So the main point what you have to remember over here, or the distinguishing feature in elastic collision, is that here the momentum and kinetic energy is conserved. And in addition to this, there are some more points over here. Here the forces that is involved in collision are conservative. You remember what are conservative forces? The basic definition that was given in conservative forces is the work done does not depend on the path followed, right? It depends only on the initial and final state of the system. That was one of the main points that was given in the case of conservative forces. And now here, the mechanical energy is not converted into heat, light, and sound, etc. So that can be the next characteristic. Mechanical energy is not converted into heat, light, sound energies, etc. So how many points we have done? One is momentum is conserved. Second point, total energy conserved. The third point, kinetic energy is conserved. And the fourth, forces involved in collision are conservative. And the fifth point, mechanical energy is not converted into heat, light, sound, energies, etc. And now here when you're looking for the collision, the examples when you're looking, mainly the collision between subatomic particles we can consider. So here we can consider example collision between subatomic particles. That is one typical example of this. Now we will see what is the difference of this elastic collision with inelastic collision. Also, basically, I'm going to see the characteristics. Along with that, we will just clearly see what are the differences. So in this case also, the momentum is conserved. And the total energy is also conserved. Now comes one of the major difference over here. The kinetic energy is not conserved in this case. That is one of the major difference. So maybe we can emphasize this with a different color. Okay. Kinetic energy is not conserved over here. And now the other properties we will see here. Here, not necessary that all the forces are conservative over here. Okay. So maybe some or all forces involved. So it might be conservative or it might not be conservative. It's like that. If forces involved are non-conservative. That's again another difference. And now the next point is that some part of the mechanical energy may be converted into heat, light, or sound, etc. May be converted to heat, light, or sound, etc. So these are the characteristics of inelastic collision. So inelastic collision, when you're considering many cases that we normally see comes under inelastic collision. Maybe it can consider the collisions between two vehicles. That can be considered as a case of inelastic collision. So what we have seen right now is what are elastic collisions and what are inelastic collision. So when you're solving the problems, the main point you have to remember is that in both the cases, momentum is conserved. And in the case of elastic collision, kinetic energy is conserved. And in the case of inelastic collision, kinetic energy is not conserved. This is the point that you have to remember while solving the questions based on this. Now we'll just see a special case. That's a perfectly inelastic collision. Okay, so that comes in a way I can tell that it comes under inelastic collision, but sometimes you can see that it's categorized as a different case itself, but still right now I'm considering under inelastic collision. Okay, we'll just see that also. Perfectly inelastic collision. So basically, if you're considering that two objects moving with certain velocity, they collide each other, and after collision, if you're finding them to be moving together, this is a perfect example of inelastic collision. Maybe you can consider a block kept on a surface and you're firing a bullet. The bullet gets embedded into that and the block and the bullet moves ahead together. This is an example of a perfectly inelastic collision. So we'll just note it down. If two objects stick together during collision and they jointly move together after collision. So this is an example of perfectly inelastic collision. Okay. And here also the momentum will be conserved. Remember that always momentum conservation is valid always if no external forces are acting on the system. Okay. So here also we will remember, you need to remember momentum is conserved and the loss of kinetic energy is maximum in this case. Loss of kinetic energy maximum. Okay. Once again, we will have a quick discussion what we have done right now. We were learning about the types of collision. So collisions are generally classified into elastic and inelastic collision. Elastic is where momentum and kinetic energy is conserved, and inelastic is where momentum is conserved but kinetic energy is not conserved. And then we have seen an example of perfectly inelastic collision.